Hello students, welcome back to our channel Diksha Karnataka. So as you all know, your COMEDK exam is approaching. So we have started a series where we will be discussing the top 30 questions from all the high weightage chapters for your chemistry exam. So in this video, I'll be discussing with the 30 questions of solutions chapter, which is a very high priority chapter from which you can expect 3 to 5 MCQs. Okay. So in this video, what you have to do is you have to revise this chapter. Okay, just go revise all the formulas and then come back and try to solve these questions. If you are able to solve these questions, you can assure that you will be able to solve the questions in exams also, because similar questions will be there in your COMEDK exam. Okay, so I hope all of you are ready with this for this series. So let us start with the first question. Okay. Okay, in this video I'll be also telling you like what are the formulas you have to use, what are the tricks, and how we can like guess the answers easily. So every question will have some tips and tricks. So please watch the video completely. Okay, so now coming to the first question. A solution contains a non-volatile solute. Okay, one second. Yeah. A solution contains a non-volatile solute of molecular mass Mb. Which of the following can be used to calculate the molecular mass of the solute in terms of osmotic pressure? Okay, so we know osmotic pressure is a colligative property where we can write pi is equal to C into R into T. And C is what here? Molarity, right? So molarity can be written as WB by MB, okay, into 1000, or let us not, 1000 we have to use if it is in ml. So let us take it like only volume. Okay, so by 1 by V into R into T. Now if I want to calculate molar mass, okay, that will be equal to WB into 1 into R into T divided by pi into V, right? So WB RT by pi V. So that is your option number B. So correct answer for this question will be option number B. Okay, I hope this question is very simple, easy, clear one. Second one, the order of freezing point of this one will, so this different compounds are given, we have to find the order of their freezing point. Okay, so this one is very tricky question. You have to understand that if the depression in freezing is more, then the freezing point will be less, right? So we have to check those where the depression in freezing point will be minimum. If the depression in the freezing point is minimum, then the freezing point will be maximum, right? So now if you see here, let us see the I values. For this one C2H5, the I value is 1. For this one the I value is 5. For the third one, that is Na2SO4, I value is 3, and then fourth one is 2, and then fifth one is 4, right? So the one which is having the minimum I value, there the depression will be minimum and boiling point will be the maximum. So C2H5OH will have the maximum maximum freezing point. So we can eliminate these all options, right? So C2H5 will be maximum, and then we have 2, that is your KCl, and then we have 3, that is Na2SO4, okay, and then we have 4, that is your Li3PO4, and then the last one is 5, that is your Ba3PO4 whole 2, right? So the correct answer for this question will be option number D. So let us see the next question. 0.5 molar of H2SO4 is diluted from 1 liter to 10 liter, the molarity of the resulting solution. Okay, so if you see here 0.5 M1, and so we have to use dilution formula, M1V1 is equal to M2V2, right? So 0.5 molar into 1 liter is equal to 10 liter into this one is M2. So if you solve this, we will get 0.05. So the correct answer for this question is option number D. Next, the diagram given below is a vapor pressure composition curve for binary solution of A and B. So in the solution, AB interactions are, so you see the vapor pressure, it is showing a positive deviation, right? So if you see, this is a positive deviation. Positive deviation means the interactions will be weaker. So what we can say, the interactions between A and B is smaller than AA and BB interaction. So the correct answer for this question is option number C. Next, what will be the mole fraction of ethanol in a sample of spirit containing 85% ethanol by mass? This is very important question. Now, what do you mean by this 85% of ethanol? So that means in 100 gram of solution, okay, 100 gram of solution, ethanol is 85 gram, right? Then if 85 gram is ethanol, then what is the mass of water? Total mass is C. Total solution is 100 gram. Out of that 85 gram is ethanol. Then 15 gram will be water, right? Now let us calculate the mole fraction for both, number of moles for both. So number of moles of ethanol will be, so if you calculate the molar mass of ethanol, that is C2H5OH, that is C2H6O, right? So this will be 46, I think. Carbon will be 24. This is 30. 30 plus 16 is 46, right? So number of moles of ethanol will be mass of ethanol, that is 85 divided by 46, and number of moles of water, that will be given mass by molar mass. So given mass is 15 and this one is 18, right? So now we have to calculate the mole fraction of ethanol. Okay. So this one will be equal to number of moles of ethanol by number of moles of ethanol plus number of moles of water. Okay. So if I have number of moles of ethanol is 85 by 46 whole divided by 85 by 46 plus 15 by 18. Okay. So now if you solve this, we'll be getting around 0.69. So the correct answer for this question is option number A. Little calculations is involved in this one, so please check the calculation and do it once again. Okay. So now let us see the next question. One second. Yeah. So what will be the degree of dissociation of 0.1 m magnesium nitrate solution if the Van 't Hoff factor is 2.74? So this question is from your Van 't Hoff factor, where we have, for dissociation, alpha dissociation is equal to I minus 1 by n minus 1, right? So we have to calculate alpha. I value given is 2.74 minus 1, and number of ions produced here will be 2 plus 1, 3, right? 3 minus 1, that is 2. So I can say it will be around 1.74 by 2. So that is around 87%. You have to just multiply it with 100, right? So we'll get 0.87, that is your 87%. So the correct answer for this question will be option number B. Next, calculate the freezing point of an aqueous solution containing 10% by mass of glucose, 5% mass of urea and 1% by mass of KCl. Kf value is given to you. Very, very important question. So in this question, 3 types of solutes are added, right? So let us first calculate the number of moles of each type of solute. So if you see here, first one is glucose, right? So number of moles of glucose will be what? Given mass by molar mass. So in this 100 gram of solution, 10 gram is glucose. So if 10 gram is glucose, so its molar mass will be 10 by 180, that is 1 by 18. Next, if you see urea, 5 gram is urea, right? So number of moles of urea will be 5 by urea mass is 60, that is 1 by 12. And then we have 1% of KCl. So number of moles of KCl. So 1 by the molar mass of KCl is how much? Potassium is 39 and this is 35.5. So we have 74.5. Okay. So these are the number of moles given for each of the species, each of the compound solute that is added. So we have your number of moles for all of them. Now what we have to do is, normal delta TB formula we will use. So what is N total here? N total is 1 by 18 plus 1 by 12 plus 1 by 74.5. So if you solve this, we'll be getting around 0.166 moles. Okay. Now if you solve this one, delta TB, okay, is equal to Kb into M, right? So we have to calculate delta TF. Okay, this is not TB, it is TF. So we have this one, delta TF is equal to Kf into M, right? So Kf value is given as 1.86. Okay, and molality value will be what? Molality will be given mass by molar mass. So the total number of moles by volume. So total number of moles is 0.166. Okay, and volume, how will you calculate? So sorry, mass of the solvent, how will you calculate? Out of 100 gram, right? Out of 100 gram of solution, this is 10 gram, this is 5 gram and this is 6 gram. So total 16 gram is solute. mass 16 gram is solute. This is the total mass of solution. So solvent mass will be 84 gram, right? So we have to substitute here 84 into 1000. Okay, so delta TB, after solving this one, the delta TB value you will be getting will be around 3.67. Okay, so this value we got, delta TF is equal to 3.67. Now if you see, this one value is what? TF, T naught F is equal to 3.67. This value is 0. So I can say TF is equal to minus 3.67. So the correct answer for this question is option number C. I'll discuss this question once again. If it is not clear, please listen carefully. We had 100 gram of solution where there was 10 gram glucose, 5 gram of urea and 1 gram of KCl. So total mass of the solute is 16 gram. So what will be the mass of solvent? 100 minus 16, that is 84 gram. Okay. Now for each of them I calculated the number of moles. 10% by mass means 10 gram is glucose. So number of moles of glucose will be 10 by 180. Similarly, for urea it will be 5 by 60 and for KCl it will be 1 by 74.5. Now if you add all this, we'll get around 0.166 moles. So now if you substitute here Kf into m, so number of moles by mass of the solvent into 1000. So once we solve this, we'll be getting around 3.67. Okay. So delta TF is 3.67. What is delta TF? T naught F minus TF. T naught F is 0. So TF value will be equal to minus 3.67. Correct answer for this question will be option number C. Next question. Which of the following does not show a positive deviation from Raoult's law? Positive deviation doesn't show means it shows negative deviation. There should be more attraction. So in benzene and chloroform, the intermolecular force increases. So that is why correct answer is option number A. Next, if this question is also important, if you know the term. If active mass of a 6% solution of a compound is 2, its molecular weight will be. Active mass means nothing but molarity. Okay. So the question here is the molarity is 2. Okay. So we know the formula for molarity. Molarity will be equal to given mass, okay, by molar mass into 1000 by volume of the solution. Right. Now if you see here, 6% means mass of the solution is 100 gram, and if you consider density is 1 gram per ml, so it is volume will be 100 ml, right? So now if you see here, we can add W is 6 divided by molarity into 1000, okay, by 100. This one is equal to 2. So now if I solve this, molarity I'll get is molar mass I'll get is 30. So the correct answer for this question is option number A. Next, a solution of two liquids boil at a temperature more than the boiling point of either of them. Hence the binary solution shows. So more than the boiling point means it is a maximum boiling azeotrope, right? This is maximum boiling azeotrope, right? So now if that is maximum boiling means at a higher temperature it is boiling, so definitely the intermolecular forces has increased, so that will show you a negative deviation. Okay, so the correct answer for this question is option number A. Next, equivalent weight of KMnO4 is equal to, so if you know equivalent weight is molar mass by n factor, right? Now in KMnO4, if you see, the KMnO4 changes from Mn plus 7 to plus 2, right? So n factor here is 5. So whatever is the equivalent mass, it is 1/5 of its molecular weight. So the correct answer for this question will be option number C. Okay, next, seawater is converted into fresh water based on the phenomenon of reverse osmosis. It is a way for desalination of water. Next, isotonic solutions have same osmotic pressure. Correct answer is option number D. The molality of 90% H2SO4 solution is. Okay, so this is an important question from concentration term. So first of all, you understand here what all data are given, and here one assumption is there that the volume of solution, okay, this has to be mentioned in the question. Volume of the solution is 1 liter. Okay, when molality is for 1 kg of the solvent. Similarly, you should assume that the volume of the solution is 1 liter. Now, if you see this here, density of the solution, okay, density of the solution is 1.8 gram per ml. Okay. Now, if I say volume of the solution is 1000 ml, okay, then what will be the mass of solution? Mass of the solution will be density into volume. So that is 1800, right? That is 1800 gram of the solution. Now this is the total mass of the solution. Now if you see here, for every 90% of H2SO4 is there, right? That means what? For every 100 gram of solution, 90 gram is H2SO4, right? Now if we have 1800 gram of solutions, okay, then so it is like 1800, how we are getting, just multiply with 18. So if I multiply here, this one is 18, this is 18 times, so this one will also become 18 times, so 1620 gram. So what I can say, in every 100 gram there is 90 gram of H2SO4, but we don't have 100 gram of solution. Our solution is how much? 1800 gram. So in 1800 gram, how much will be the mass of H2SO4? So I can say now the mass of H2SO4 is 1800 gram. Clear? So now if you see here, we need mass of H2SO4 is 1620 gram. Okay, so 1620 gram. So we have found out two things. Mass of the solution is 1800 gram and mass of the solute is 1620 gram. For molality, we need mass of the solvent. So if I want to calculate mass of solvent, so how we can do that? Mass of solvent will be 1800 divided by 1800 minus 620, that is 180 gram, right? So I got now mass of the solvent. So now we can directly use the molality formula. Molality will be equal to mass of the solute, that is 1620, by molar mass, that is 98, into 1000 by the mass of the solution, 180. So if you solve this, we will be getting around 91.8. Correct answer for this question is option number C. Okay. So this question is little tricky. I want to explain it again for those who didn't understand. Those who have understood can go forward it and go to the next question. Okay. So I'll erase it and repeat once again. So those who didn't understand, please check once more time. This is a little tricky question. The question is, it is given density is 1.8 gram per ml. Okay. Let the volume of solution, okay, let the volume of solution is 1000 ml. Okay. Then what is the mass of solution? Okay. Mass of solution is 1000 into 1.8, that is your 1800 gram. Okay. So we got this is the mass of the solution. Now 90% means for every 100 gram, the mass of the solute will be 90 gram. Means if you take 100 gram of the solution, there will be 90 gram of H2SO4. Okay. But we don't have 100 gram, we have 1800 gram. So if 100 gram contains 90 gram, then 1 gram will contain 90 by 100 and 1800 gram will contain 90 by 100 into 1800, right? So that will give you 1620 gram, right? So total mass of solution is 1800 gram, mass of solute is 1620 gram. Then what will be the mass of solvent? You have to subtract these two to get 180 gram. Now after subtracting, we got the mass of solvent. Here you can calculate molality. Molality will be given mass by molar mass. So given mass of the solute is 1620. Molar mass is 98 gram into 1000. Okay. And then mass of the solvent is 180 gram. So now if you solve this, we'll be getting around 91.8. So the correct answer will be option number C. The next question, the solution having the lowest freezing point. Okay, so if you see the formula for freezing point, delta TF is equal to KF into M, right? Now if I want to expand this molality and write, it is given mass by molar mass into 1000 by mass of the solvent. So if you see, the molarity is same for all. So whosever molar mass will be highest, its freezing point will be least. So if you see potassium chloride, potassium sulfate, potassium nitrate and aluminum sulfate mass will be higher. So if mass is higher, the freezing point will be less. So the correct answer for this question will be option number D. Okay. Next. Okay. Partial vapor pressure of a solution component is directly proportional to its mole fraction. This is your Raoult's law. Correct answer is option number A. Next, which of the following compounds have the same Van 't Hoff factor as of aluminium sulfate? So in aluminium sulfate, how many I value will be? It will dissociate as 2Al3 plus 3SO4, 2 minus. So total we get 5 ions, right? Now if you see here there will be 4 ions and 1 complex ion, that is your again 5 ions. So the correct answer for this question is option number A. Next, when the concentration is expressed as number of moles of solute per kg of the solvent, right? So this is your molality. So the correct answer for this question is option number B. Next, Van 't Hoff factors of equimolar solutions of sodium chloride, barium chloride and glucose in water are. So we have sodium chloride, barium chloride and glucose. Okay. So sodium chloride has 2 ions, barium chloride will give you 3 ions and glucose is a non-electrolyte, so it will not dissociate. The I value will be considered as 1 here. So the correct answer for this question will be option number D. Next, 1 molar solution of sodium chloride in water has the same boiling point as. So if NaCl is there, okay, 1 molar, if both are 1 molar, so if you see delta Tb is equal to I into M into Kb, right? So all are 1 molar here, molality will be same. So whosever I value will be same, that will have the same boiling point. So if you see for NaCl, the I value is 2, Na plus and Cl minus. If you see magnesium sulfate, here also I is 2. Here I will be 3. Magnesium chloride formula is like this. 3 ions will get. Aluminium sulfate is Al2SO4 whole 3. So here I value is 5 and here it is aluminium chloride. So here it is I value is 4. So the correct answer for this question will be option number A. Next, the vapor pressure of water at 293 Kelvin is 17.535 millimeter Hg. The vapor pressure of water at 293 Kelvin containing 25 gram of glucose dissolved in 450 gram of water is. Okay, so this question we have the relative lowering of vapor pressure formula to solve it. But without seeing that also we can easily solve it. So whenever like we know, whenever any solute is dissolved in any solvent, its vapor pressure will decrease, right? So what was the original vapor pressure of water? 17.535. So the new vapor pressure of the water will definitely be less than 17.535. So we can eliminate this option and this option, right? Now when it decreases little, like a few, there is not like from 17 it will become 0.097, right? So this option is also incorrect. The most relatable option will be your option number A, because it has decreased and the decrease is also not very drastic. But how to solve it with formula, I'll tell you. The formula will be P naught minus P by P naught is equal to XB, right? So now let us first calculate all the values here. So what is the number of moles of glucose? Number of moles of glucose will be 25 by 180, given mass by molar mass, and number of moles of water will be around 450 by 18, right? So what is the, when you calculate XB, we take NB by NA, right? Here we neglect this NB in the denominator is neglected because NA will be like it will be very large than NB, so it can be neglected. So now if I solve this one, so XB will be equal to 25 by 180, okay, and then into 450 by 18, okay. So here we can cancel, so we'll get 1 by 180. Now I can substitute all values. What is your P naught value? 17.535 minus P by 17.535 is equal to 1 by 180. Okay. Now if you solve this, the p value will be coming around 17.439. So the correct answer will be option number A. Without solving this also, you can easily tell the answer, because the vapor pressure has to decrease when a solvent is mixed with any non-volatile solute. Next question, which of the following is not satisfied by an ideal solution? So delta V mix 0 is correct, Aube-Raoult's law is correct, delta H mix is correct, delta S mix is not equal to 0. Whenever mixing happens, entropy always increases. So this value should be greater than 0. Okay, correct answer is option number B. Next, the mole fraction of benzene in a solution containing 39% by mass in an organic solvent of molecular mass 122 is. Okay, so this question is, we have benzene here, benzene and one organic solvent is given to you. Okay, and the percentage of benzene is 39%, means benzene mass is 39 gram and this one will be obviously 61 gram, right? Now, and then the molar mass of this one is 122 and the molar mass of benzene is C6H6, so that is your 72 plus 6, that is 78, right? So we will get this one as 78 gram. So what is the number of moles of benzene? Number of moles of benzene will be given mass by molar mass, so 39 by 78, that is 1 by 2 or 0.5, and number of moles of this organic solvent will be 61 by 122, that is also 0.5. So when both are equimolar, the mole fraction will also be 0.5, so you can also calculate here. So mole fraction of benzene will be 0.5 by 0.5 plus 0.5, that is your 0.5. Correct answer will be option number A. Okay, next, the mass of a non-volatile solute of molar mass 60 gram per mole that should be dissolved in 126 gram of water to reduce its vapor pressure to 99% will be. Okay, so this is again, the question is from relative lowering of vapor pressure. So if you see here, P value is 99% of P naught. Okay, so I can write it as 0.99 P naught. Okay, so we have this formula, P naught minus P by P naught is equal to XP. Okay, so let us first calculate here XP. The non-volatile solute is 60. We have to calculate what is the number of moles. So N of the solute, number of moles of solute will be given mass by molar mass, that is 60, and number of moles of solvent. Okay, the solvent here is your water, so 126 gram by 80, right? So if I calculate this one, P naught value is, let us keep it as P naught. P is 0.99 P naught minus divided by P naught will be equal to, XB value is W2 by 60 into 126 by 18. Okay, so this one we can write it as 0.01 equal to W2 by 60 into 18 by 126. Okay, so we can easily solve this one. So we have here 4.2 something we will get. So the near answer is your 4 gram. So correct answer for this question will be option number A. Okay, next question. 2 gram of a non-volatile solute, non-volatile water soluble compound is dissolved in 100 gram of water. The elevation is in boiling point is found to be 0.26. The molecular mass of the compound X is dash. So given value is this one. So this is a direct question from your elevation in boiling point colligative property. So we have this formula, delta TB is equal to KB into M. For M we can write it as W2 by M2 into 1000 by W1. Okay, so now if you see here, delta TB is 0.26, KB is 0.52, then W2 value is 2 gram. Okay, M2 value is we have to find out, and 1000 by mass of the solvent is 100 gram. Okay, so if we solve this, we'll get M2 value as 5.2 into 2 by 0.26. Okay, so Okay, so if you solve this, it will be 40, we'll get 40. Okay, so the correct answer for this question will be option number D, that is 40 gram per mole. Next, to prepare 2 decimeter cube of decinormal solution of oxalic acid, the mass of the oxalic acid required is, okay, so this question is from your concentration term, normality, right? So for oxalic acid, if you know the formula of oxalic acid is H2C2O4, N factor for this one is 2. So if you calculate the equivalent mass of H2C2O4, okay, equivalent mass of H2SO4 is 63 gram. 63 is the equivalent mass of H2C2O4. Now normality formula is what? Number of equivalents by volume in liter, right? Number of equivalents is what? Given mass by equivalent mass. So given mass of oxalic acid is, we have to calculate that one, and normality is 1 by 10, so 0.1. Given mass we will calculate here. Equivalent mass is 63 into 1000. Okay, no need to 1000 because 2 decimeter cube is always, like 1 decimeter cube is 1 liter. So 2 decimeter cube means 2 liter, right? So volume is 1 by 2. So if you solve this, we will get to 12.6 gram. Okay, so the correct answer for this question is option number C, that is 12.6 gram. Next, 25 ml of 0.08 NaHCl neutralizes 20 ml of NaOH. The mass of NaOH present in 5 liter is, okay. So this question is again from neutralization process. So in whenever one acid and base neutralization takes place, we should know number of equivalents of acid will be equal to number of equivalent of base, right? And the formula for, like we have for normality, the formula is number of equivalents by volume in ml into 1000, right? So number of equivalents will be equal to normality into volume by 1000. It will be equal to number of equivalents. So now for this one, for acid it is HCl, and in case of base it is NaOH. So if you let us first find out the number of equivalent of acid, and then we'll calculate the number of equivalent of base. So if you want to calculate number of equivalent of acid here, so normality is 0.08, okay, and volume is 25, and we have 1000 at the denominator, okay. So we will have 40 here, so we can have this one, right? So this will be 1 by 500. This is the number of equivalents of acid. Now this one should be equal to number of equivalent of base. So base is 1 by 20, so normality into 20 by 1000. Okay, so we can cancel here. We will get normality is equal to 1 by 100, or that is 0.01. Okay, so number of normality here for base is, normality of base is 0.01. Okay, now that means 0.01 equivalents are present in 1 liter. Now the question has asked for 5 decimeter cube, means 5 liters. So in 1 liter there is 0.01 equivalents of NaOH. Then in 5 liter it will be 0.05 equivalents of NaOH. Okay, now in case of NaOH, the N factor is 1, so whatever is the number of equivalents, same will be the number of moles. So we can say here that it is also equal to 0.05 moles of NaOH. Okay, now the question has asked to calculate the mass. So if no moles is known, we can calculate the mass by multiplying with the molar mass. So for NaOH, the molar mass is 40 gram per mole. So we can multiply this one with 0.05 into 40, right? So we will get here 20 gram. Okay, so the correct answer for this question will be option number A. Okay, next question. Next question is, the solubility of a substance in a solvent depends on. So the solubility depends on all the 3 factors: temperature, pressure, nature of the solute, and solvent. So the correct answer for this question will be option number D. Next, choose the ideal solution from the following. So ideal solutions are those solutions which obeys your Raoult's law. So carbon disulfide and acetone is a non-ideal solution. Phenol and alanine is also non-ideal because there is the hydrogen bonding takes place and intermolecular force increases. Okay, same in case of chloroform and acetone, but ethyl iodide and ethyl bromide forms a ideal solution. So the correct answer for this question will be option number D. You should remember the examples of ideal solution and non-ideal solution, and in non-ideal solution also positive deviation and negative deviation. At least 2-3 examples you must remember, which is given in your NCERT book. Okay. Next, choose the correct example for a non-ideal solution. So here the previous one was, okay, so benzene and toluene, non-ideal solution. What are the conditions? They should have, they should not follow Raoult's law. Okay, that does not obey Raoult's law. So whenever there is a, like, if the intermolecular forces increases, the attraction increases, they will form, like, either the attraction should increase or it should decrease, they will form a non-ideal solution. So benzene and toluene forms ideal solution, hexane and heptane is also ideal solution, chlorobenzene, bromobenzene is also ideal solution, but ethanol and hexane is a non-ideal solution because ethanol has what? Hydrogen bonding. But when you add hexane to ethanol, the hydrogen bonding gets disrupted. So that is why it forms a non-ideal solution. Okay. So the correct answer for this question will be option number D. So these were the top 30 questions from the solutions chapter. So you can revise them, all the concepts or the formulas, and just practice these questions, and similar questions you can practice. We also have a video on top 30 questions on solutions chapter for the KCET exam. So after doing this, you can go and watch those questions and practice those questions also. Okay. And if you have any doubt in any question, please comment down. We'll address it in the next video. So if you have found this video helpful, please like, share and subscribe our channel. Thank you.